Hey folks. Okay, well, we talked about grammars and regular expressions and context-free grammars and augmented grammars. Now we want to look at trying to apply some of that stuff using lex and using yacc. So lex, our lexical analyzer, is going to be used to tokenize code in a specific language, and yacc is going to be used, yet another compiler, to go through and apply the parsing and the semantic rules and semantic analysis to our programs. And again, they're both based on the idea that we come up with a grammar describing the rules of the language. So lex and yacc will produce the tokenizing and parsing tools for us. So ultimately what we're going to do possibly is to use lex and yacc to produce a program for us that maybe does analysis of programs written in a language to give us an analysis of whether or not they're valid programs. Tell us what the syntax errors are, tell us what the semantics errors are, or maybe we can use it to go through and produce a compiler for the language that we're trying to develop. But again, they're all based on this idea of we provide a grammar describing the language, we tell lex and yacc what we want done with the different tokens and different rules that it finds when it's going through and analyzing a source code program based on the grammar rules, and then it produces the tool for us. But the syntax for lex and the syntax for yacc are a little unusual. It takes a little bit of getting used to, and we have to be fairly careful with our grammar rules and whatnot. So we'll see what we can do to try and familiarize ourselves with this here. Let's see now. So the basic sequence is that if we've got some language L that we want to be able to process, so I've got my great new whiz-bang language that I've just made up, and I want to be able to create tools that process programs written in that language. So I'm going to create an l.lex file that's got the tokenizing rules for L, and an l.yacc file that's got the parsing rules for L. And then I'm going to go through this sequence of compilation steps. I'm going to run lex on the .lex file, yacc on the .yacc file, and then I'm going to compile the results together to produce my analysis tool. So again, it's a multi-step process. Usually you're going to embed this stuff in a make file. And eventually this analysis tool that it produces for us is what we're going to run on our source code programs. So if I've got some source code that's written in L, I'm just going to run my analysis program and take that as the standard input for it. And it'll go through and do the tokenizing and parsing and tell me whether this is a good program or a bad program, or it's going to produce a translation of it or a compilation of it or whatever it might be, depending on what I told lex and yacc to do. So again, usually you're going to provide a make file for this. So just to take a quick look at that. Let's say that I've got this made-up language and I've got a sample program written in that language just to try things out. But let's say that my language just consists of some programs in the language have to start with an open curly bracket, end with a closing curly bracket, and then they can have a bunch of print statements inside them, or maybe just one print statement inside them. Let's start simple. They've got a print statement inside them that just accepts a single integer. So a sample program might look like something like this, where, oops, that's a broken one. Let me get rid of the broken part there. So a sample program might look like this: open curly bracket, print some integer value, and a close curly bracket. So that's all the programs can be. It's just open curly bracket, print some integer, and a close curly bracket. So start off fairly simple. So the lex rules for my language, I'll put in this x.lex. The yacc rules, I'll put in x.yacc. We'll take a look at those later after we talk about them a little bit. But for the moment, I'm just going to take a look at the make file here. So the make file, I'm going to have a pair of builds here. I'm going to have the first one that does some dependency building for me. So it's going to go through and run, it's going to be based on the existence of my .lex and .yacc files. It's going to run lex on my .lex and yacc on my .yacc, and it's going to produce a y.tab and a lex.yy file, and it's going to compile them together. The -d is in here just to tell it essentially that if these things don't already exist, then create them for me. So it's going to go through this intermediate stage where it generates these files, and then I'm going to create the real version. So my real executable, my real analysis tool is going to be this program named X, and it's going to depend on this one having been done first. And again, it's just going to run lex and run yacc on my .lex and my .yacc, compile them together and produce the program that I want. So it's not stuff that you want to sit down and memorize and run by hand every time. So you put together a make file like this that's got the rules in it, and essentially just say make whenever I want to update my analysis tool, my executable. And I've thrown in a clean as well here to get rid of the y.tabs and the assorted other bits and pieces, the executables. So what it's going to look like if I try running this is, again, it's going to go through, run the lex and yacc with the dependency flags, compile those. It's going to run my lex and yacc for real and compile those, and eventually produce my executable here that I can then use to say, well, is this sample program okay? Compilation begins, compilation ends, nothing went wrong, so I'm going to assume that my sample program is okay. So for instance, if I put some junk in my sample program there and try it again, it tells me, there's some kind of garbage in there, it's not a valid program. Now, all of this, of course, is based on the idea that I've created this x.lex file that's got my lex rules, and this x.yacc that's got my yacc rules. So let's go back and talk about those. So the files themselves are each broken up into 3 sections, kind of a preliminary section, a rules section, and then a kind of C section at the bottom. So these 3 sections are each separated by these pairs of characters, %%. That's the marker that tells lex or tells yacc that I'm moving from one section to the next. So for the lex file, the first section is used for defining some character sets. So if I want to give a name for the alphabetic characters or a name for the digits, then I can define those. And also to put in any C library includes any C prototypes for functions I want to create or want to use, global variables, type definitions, that kind of thing. So this first section is basically some setup info. And then the second section is where we'll have our actual tokenizing rules and the code that we're supposed to, essentially C code that we're supposed to run when we identify a token. And then the final section will have any of the implementations of functions that we prototyped up in that first section. So essentially these are things that we'll be able to call in that second section if we want to. So let's take a look at that. So we'll have a bit of a look at our sample lex file here. So you can use C-style comments, but just a word of warning, leave a space beforehand. Otherwise, lex is going to get all confused when it runs. Now remember, this isn't getting compiled directly as C. This gets run through the lex program. So the lex program is expecting to see things in the layout that it's expecting, which isn't quite pure C. So if you're going to throw C-style comments in, do make sure you indent them a spacey. So in this first section, I might have a bunch of comments. In this particular example, I'm going to make use of alphabetic characters and I'm going to make use of digits. So I'm going to give a regular expression for alphabetic characters. They're just any upper or lowercase alphabetic. A digit is, any of the 10 digits. And then it's got the section of C includes, type definitions, function prototypes, etc. Anything that I want to use there. The couple that are mentioned here, YYLVAL and YYWrap and YYError, are special ones that we're going to include no matter what and make use of. I'll talk about those in a bit. you will see that this C section is stuck inside this % open curly bracket and % close curly bracket. Again, this is to tell Lex that here comes the beginning of my C stuff, and here's the end of my C stuff. And again, that % I mentioned says, okay, you're telling Lex I'm at the end of that opening section. What's coming next is the rules section. So in that rules section, I give a regular expression for every kind of token that I'm interested in the order that, the kind of priority order for them, which order you should check when you're going through characters. See if it's one of these things first, and if it's not one of those, see if it's one of these. If it's not one of these, see if it's one of these, and if et cetera, et cetera, et cetera. So it just says, see if the next thing is one of these tokens. And if it is one of these tokens, do whatever's in the curly brackets over here. So whatever's in the curly brackets is pretty much going to be C code. So what we're going to do for each of these is we can do a bunch of C stuff that we'll get into later, and then we're going to return a value that specifies what kind of token we've just found. So for each of these, in all caps, I'm going to give a name to each of my different token types. So I decide that a bunch of digits is an int. An open curly bracket is an open scope. You know, whatever name you want to give to that token type. A closed curly bracket is a closed scope. The print is going to be a print token type. So for each of the token types I'm interested in, I just have something over here that says, okay, return, I found this kind of token. And again, you can have regular expressions here, or you can have just plain text. You know, if you've got keywords, then you can just have whatever the actual text is for that keyword. Now, I would like this thing to skip over white space, essentially ignore white space. So I'm going to give it the expression for what a white space character is. Actually, I guess I could have named that in my section up top too. But so a space, a tab, or a new line is going to be white space as far as I'm concerned. If you see any of those things, just ignore it. Just skip it over, right? So it's not doing anything. So if you see any one of these tokens, return the right token type. If you see white space, just ignore it and move on to the next thing. And anything else, anything that's not one of those tokens and isn't white space, I'm going to say is bad text, is bad character. It means we've got an invalid program. So the dot, again, represents anything else. If you see anything else, then do whatever this is. And actually, again, we'll come back and talk about this, but I'm setting things up to display an error message if you see bad text. And then at the very end, right, in that final section after that second %%, we're going to have the implementations of the functions that we mentioned back at the top in the prototypes. So I'm going to have one function for YYWrap, and this is automatically run at the end of the grand glorious process we go through here to clean up anything that needs cleaning up. So if you find yourself doing any dynamic allocation in the C code and C functions you write, you can clean that up here. If there's any summary stuff you want run, you can do that here. And YYError is one that's going to get called if anything goes wrong, essentially. And so for YYError, I'm going to say, okay, well, I'm expecting it to get past a parameter that's just the text to print out when this error happens. And I'm just going to get it to print to standard error, this went wrong, and whatever the message is. So these two we're going to pretty much always use. And if you want to create any additional C functions, you can, again, prototype them up in the top here, and then just make sure you give an implementation of them down at the bottom. And you can quite happily call them in any of these chunks before you do your return statements. So we've got our .lex. The .yacc is going to have kind of a similar structure when we get there to take a look at it. All righty. So we've got these three sections, right? Any useful character sets, the C setup, the token rules, and then the C functions. So this is pretty much just a summary. We just looked at a more detailed example where we've got the three sections. Now, again, the various files that we were discussing are going to get auto-generated. Once you've got your makefile set up, you really don't have to worry about that anymore. yacc, again, is that function that's automatically called at the end to do any kind of cleanup you want. Just a heads up that yacc, you want to return a 1 if things went okay. Otherwise, it's going to think that the processing did not work correctly. And again, error is what we're going to use to display text error messages if anything goes wrong. And again, typically you get it to display the string and return 1. So that declaration section that we went through, right, in the percent open curly bracket and percent closing curly bracket, is where we did any of our C declarations that we were going to use in the rest of it. And any of those things can be used in the rest of your .lex and your .yacc. For any of the prototypes, then somewhere down at the bottom in that final section, you have to give an implementation for it. And in that declaration section, again, you can do things like say, okay, well, here's the alphabetic characters I'm interested in. Here's the digits I'm interested in. Here's the white space characters I'm interested in. So you just give it a name and the regular expression for it. And then in that second section, we had the token rules. So again, each of them had a regular expression and then a C block dictating what to do with it. And if it was a valid token, then you get it to return that token type. Now, we're going to wind up using these things in the yacc file that we create later, but we'll get back to that. The .yacc and .lex, of course, are really tightly interrelated. Now, for the token rules, you do need to make sure that you've thought about the order these things are done in. For instance, if you decide that you've got a token that represents identifiers that can be any sequence of alphabetic characters, and you've got another token that's the keyword void or the keyword begin or something like that, then under those rules, begin could be either an identifier or our keyword. So if we want to make sure it catches the keywords, we have to put those first. Right? So make sure that you kind of prioritize the order of your rules so that they're checked in the order you want them checked in. All right. Again, we've had a little bit of a look through the example in the other file, but if we've got something like identifier as one of our desired token types, and an identifier is just going to be a bunch of alphabetic characters, then we could quite happily give a regular expression for it and say, okay, if you see a bunch of alphabetic characters in a row, treat that as an identifier. Now, things will eventually get a little bit more interesting. Suppose I decide that for things like, if I see an integer, if I see 37, then I want to give that a token type of integer, but I also want to remember what the actual integer value was. Or if I see a string literal, I want to give it a token type of stringlit, but I want to record what the actual string is. Or if I see an identifier, I want to give it a token type of identifier, for instance, but I want to remember, what was the actual name of the identifier? Was it X? Was it foo? Was it what? So each of the different tokens is going to have a value associated with it that's going to be this YYL-val. So this is a data value that's automatically associated with each token. You can almost think of it as kind of like a local variable for that particular token. And as we're going through the token rules, there's another variable called YYText that is going to have the string that we're currently looking at in the input stream. So if we go back to that example, going through here, for instance, if I'm reading through the sample program we had before that was an open curly bracket, print 17 or something like that, and a closed curly bracket, as it's going through and it reads the open curly bracket, that YYText is going to have essentially the string open curly bracket and null terminator. And so I can use YYText in here, and Similarly, if I go through when I get to the print statement, for instance, that YY text is going to have print in it. So I can use YY text in here if I want to. And I can associate values with the different tokens. So for instance, if I see the 17, then I want it to return a token type of int, but maybe I also want it to store the actual value 17 as the value to be associated with that particular token. So this is stuff that we want to be able to do, and in our next example we'll play with that a little bit. We'll start expanding our code to work with these YYLVAL or YYLVAL and YY text vals. Let's see, let me, I can't remember if I did this in yacc1 or yacc2. I did it in yacc2. So in this particular case, what we're going to do, so this is a pretty similar idea. We've still got our digits, our open curly bracket, our closed curly bracket, and our prints. But now what I'm going to do is when I see a digit, I'm going to remember what the actual value, or when I see an integer, I'm going to remember what the actual integer value was. So YY text has got the characters that I saw for this. So if it was a 17 in the file that we just recognized, then it's looking at it as the character string 17\0, right, the null terminator. So what I'm going to do is say, okay, the value that I want associated, the YYLVAL that I want associated with that particular token is this 17. So I'm going to run a to I, which is this built-in routine to try and convert text to integers. I'm going to run it on my YY text. And this is basically saying, okay, convert that text into an integer and store it in YYLVAL. Now, there's all sorts of different tokens. And so for some of them, maybe I want to store a string. For some of them, I want to store an integer. For some of them, maybe I want to store a struct that's got a whole bunch of different pieces of information in it. So what I'm going to do over in my .yacc file is come up with a bunch of different fields that say, okay, if I want to store an integer, I'm going to store it in a field called .num. If I want to store a string, I'm going to store it in a field called .str or something like that. So I can come up with different names for the different kinds of information that I want to store. And then I'm going to make use of that in my actual tokenizing process here. If I see a digit, then figure out, or if I see a string representing an integer value, figure out what the actual integer value is and store it in the right field of my YYLVAL. And then say, okay, I saw an integer. So this is the kind of process that we want to go through. You can ignore the columns and whatnot for now. So this YYLVAL and YY text are fields that we're going to use quite a bit as we're going through the process. Again, as we're reading through the file, YY text is just the string that we're currently looking at, the sequence of characters that we're looking at for the current token. And YYLVAL is the information that we want to store permanently associated with that token. All right. So back to our description here. As we're going through, again, as we're reading through the different tokens, as we see the tokens, we want to take a look at the actual text for that token and figure out if there's values we want to associate with it. So if there's values we want to associate with it, there'll be the different data types will be defined in the .yacc file, but we'll actually store them here when we recognize them. We'll store them in our .lex file. When we spot that kind of a token, we'll set up the correct values in YYLVAL. So again, let's say we've got a an identifier token type, where if I see a variable name, essentially, I want to remember that it's an identifier and specifically what the text is for that identifier. So ytext is this variable that's temporarily got the token contents stored in it. That's going to get overwritten the next time we write a token, so we can't just leave it in ytext. We want to copy it into the yyLval for the current token. So let's say that I'm going to use sequences of alphabetic characters represent an identifier. So if I see them, I want to return identifier. But maybe what I'll do is copy ytext into yyLval. So again, remember these are essentially a character array. So I want to copy that into my yyLval. Now, again, I'm going to have to have set yyLval up appropriately. So we'll get into an example of that in just a second. Actually, we'll get into that more clearly when we look at the .yacc file, because that's where we set up the different data types for our yyLval. Alrighty. So for each different type of token, the .yacc file can tell us, can specify, okay, if it's this kind of token, I want yyLval to be an int. If it's that kind of token, I want it to be a char. If it's this other kind of token, I want it to be a string. If it's this other type of token, I want it to be a struct that's got all these different fields in it. And then in the .lex code, we actually use the right type for that kind of token. And again, in our lex, we can make use of any of the global variables and any of the type definitions and things that we declared in that definition section up at the top. So let's take a look at just one more example here on playing with that kind of thing. So for this one, we've taken essentially that same example, our little print program language, only this time, in addition to keeping track of the tokens that we're seeing, we're also going to go through, and as we read through the source code file, we'll keep track of what row we're on and what column we're on. You know, for instance, if there's an error message, then we can say, oh, you know, we got to row 17, column 25, and then it blew up. We saw something invalid. So what we'll do is we'll declare variables for the row and column, right? So these are basically just global C variables that we're defining in our declaration section up top. I'm going to have column starts off at 0, row starts off at 0. And then as we read through the tokens, I'm going to adjust the row and the column appropriately. So if I see something like 127, I'm going to say, oh, that's a digit. Since it's 3 characters long, I've moved 3 columns over. So I'm going to adjust my column by the length of that particular token. Right? So this is going to go through string length, looks up, you know, how many characters there were in the token, and adjusts the column. And after it does that, then it returns, okay, I saw an integer. If I see an open or a closed curly bracket, I can say, oh, well, I saw one more character, you know, I read one more character, I'm 1 character further, so my column goes up by 1. And again, I return the token type. If I see the print keyword, it's the print token type, and I've read 5 characters, so my column goes up by 5. If I see a space, then maybe I say my column goes up by 1. If I see a tab, I guess debatably you can either say I've moved 1 column over or however many characters your tab is supposed to represent. But again, adjust the column that we're in for the number of characters that we've seen. I want to treat new lines separately this time from the rest of the white space. If I see a new line, that means I've moved to the beginning of the next line. So my row goes up by 1 and my column goes back to 0. Right? So this is just going through as we read through the program and saying, you know, something went wrong. Or, pardon me, we've adjusted our row and column. You know, anything else is an error. Maybe I throw something in here that says, okay, well, if it's an error, then it's just a single character. My column goes up by 1. But doing my error handling in there as well. So I'm making use of these global variables that I created. And in this case, I can tweak my error handling routine, my error printing routine, my YY error, so that now in addition to printing the actual error message, it also tells me what row and column I was on when I realized there was a problem. So now, if I do my X for my sample program, so if the program's okay, then everything worked out nicely. But if I, again, say something like wah, so I get some kind of garbage in here, then it sees that B and says, that's a bad character, that's not right. And it tells me which row I was on and which column I was in when it saw that bad character. All right, so we'll get a specific error message for the character from our token routine, and then we'll get a generic final error message as well. However, let's see. So we can go through and make use of variables that we declared in that top section. Right? We can start adding C code. Where are we here? Again, I can create other functions in here and call them from within the C code that I've got to process individual tokens. As we saw from the other section we were looking at, I can go through and set YYL values for the different tokens that we're encountering. You know, remember what the actual text was, or remember what the integer value was. And we'll make use of those in the .yacc file later on. Alrighty. So this is going through pretty much the idea that we were just looking at setting up something like our rows and columns to keep track of where we are. Now we can have as many token rules as we like. The code that goes along with them can be as complex as you like. You can make the YYLVal, once we get over to the .yacc file, you can make the YYLVal as complex as you like, so you can have, again, data types that are structs or structs of structs or whatever it might be. Again, we'll come back and take a look at that in our next section when we talk about the yacc files. So all sorts of different things that we can do with this. We can go through, and if we want to, when we see an identifier, for instance, we could create a data type that was a symbol table of some kind, and when we see a global variable for our symbol table, and when we see a new token type, we can go through and add it to this symbol table, right, with all the associated values that go along with it. All sorts of different things that we can do when we're putting together our Lex files. And again, that final C section, we can have as many functions as we like in there, and they can be as complex as we like. All right, that was everything I wanted to do in terms of the introduction to Lex. What we'll do next is an introduction to yacc. And once we've got the two of them and we can see how they're related to one another, then we can start getting much fancier about the processing that we actually do. So I will leave it there for now.